You have to start.
I have to start.
Of course, you are the one doing the interview. I'm not the one interviewing you.
Cool. All right, second episode. We're actually sitting in a rainy Gothenburg, looking out over the city at this amazing balcony somewhere inside of Gothenburg. And today I'm very excited because I have the good friend of mine, one of the best persons I know in the cryptography field. I got Francisco, aka Klondike, with me. How are you today?
I'm doing really well, thank you.
So who are you?
Well, where to start? I have been doing security for, I think it's been more than 10 years already. Time so flies. And I started on the cryptography field really early when I started with my studies, because it was really close to mathematics, which was one of my field of expertise. I have been I have had a strong interest in cryptography since then, basically.
How did you fall in the security field? Because I know you as a pen tester and a very security savvy guy. So how did that start? And what's your what led you that way?
Well, the first thing is that long time ago I discovered this project that was called Gen2 Hardened.
Gen2 Hardened, yeah.
Yes. So that was even before I started my studies at university. I discovered this forum for hackers where you could ask for help with computer problems and so on.
Yeah.
And at some point I decided that I had to set up my own web server, because that was on the early 2000s, and it was like, yeah, having your own web server is the cool thing. Everybody does that. So I wanted to do it in a way that was reasonably secure, and people there started telling me, have you heard about this Gen2 Hardened project? And this Gen2 Hardened project, and eventually I went and checked it out. It was really cool stuff. So at some point I became a developer of the project and everything.
So you just jumped into the Gento rabbit hole and been there ever since?
Yeah, well,
or did you flirt with other systems? Or
no, I have played with everything. I have played. My first distro actually was Khaled Security Advisor. I think eventually is one of the distros that became part of Kali.
Okay. Didn't Red Hat buy that, or I might be wrong on that?
No, Kali is not owned by Red Hat as far as I know. It's based on Debian, if I recall correctly.
Yeah, it is.
So this security auditor distribution, which came on a really nice CD, was really good if you wanted to crack Wi-Fi's. We are talking about a time when you could actually crack Wi-Fi's because they were using the wired encrypted privacy protocol. And from there I started working on my own. I discovered Ubuntu. But on the server, I first tried to install Fedora. I didn't like it. And I got advised to try Gentoo. And I ended up on a corner crying, asking for help, because I could not get Gentoo working out of the box at first. No, don't laugh, because, back then, Gentoo came into this really cool live CD that had this really nice graphical installer that crashed every time I tried to use it.
Why did it crash? Was it not compatible, or?
I don't know, or maybe there was not enough memory on the system. I have no idea. All I know is that after 2 hours setting up every option that I wanted to set on the system following the graphical installer and clicking on install, the whole thing crashed. Then I tried it again, and the whole thing crashed again, and it was like, what the fuck? And they were like, follow the handbook. The handbook is an instruction manual on how to set up Gentoo manually. Follow the handbook, and I was like, but I want to use the graphical installer, it's just crashing. And they were like, no, follow the handbook. Eventually I did follow the handbook, and yeah, that actually worked. So I should have chosen follow the handbook from the start.
When was this? Early 2000s, you said?
That was, let's see, 2005 or 2006.
When was Gentoo started?
2003 or 2001.
Oh, so it was really early in the Gentoo days, huh?
Relatively early, yes. So the point is that that was when the Gentoo community was growing a lot also. A lot of new people coming in and so on. So that was really long time ago. I mean, now the Gentoo community is lingering. There is not that many new people coming in, and I'm not sure whether we are actually keeping the same, more or less, amount of developers over time, or we are actually losing developers.
Oh. Yeah, I could imagine, because I guess the demand was a lot higher back in 2005 when there wasn't so many options for developers and hackers to use.
It was not just a matter of options. It's also so back then there were basically three kinds of Gentoo users.
Yes.
People like me that cared a lot about security and wanted to use Gentoo hardened with everything that entails, and that works best when you compile everything from zero. People that is really concerned about the performance of their systems. We used to call them jokingly risers, like
a riser.
that try to use Gentoo because by compiling with a lot of compilation options and optimizations, they could get 1% improvement on the performance of the software on their system at the expense of having to compile everything again and again and again. And the last group of users were people that wanted to have the ability to choose and control almost everything on their system. In a way, Gentoo is and was Linux from scratch with a really nice client to use CLI interface that you could use for installing packages and so on, instead of having to compile everything manually.
Could we jump into Gentoo hardened?
Yes.
What's the difference between regular Gentoo and Gentoo hardened, and what is hardened?
So now the difference is not as big as it used to. Gentoo hardened sets up by default slightly stronger compilation options like better SSP protection, that is for preventing stack overflows. If I recall correctly, by default Gentoo hardened uses position independent code for compilation, both on AMD 64 and x86. I'm not totally sure that Gentoo uses position independent core by default now on x86. On AMD 64 is kind of default nowadays. Yep. Then we were also providing different hardening options from the compiler enabled by default, but a lot of these options are now enabled by default by the standard Gentoo compiler. So there is still some pretty few hardening options that are not provided, but that's not such a big difference. The other big point of Gentoo hardened is that the binaries and everything that you compile was compatible with the yearsec patches. So we had the hardened sources that were basically the yearsec patches plus some custom Gentoo patches that were not significant differences. Most of that work with the kernel was maintained by a developer called Blueness.
And the yearsec patches, those were hardened Linux images.
Yes.
Correct. Yeah.
Also, we also have the Linux project as part of the Gentoo hardened project that tries to set up a mandatory access control policy so that you can restrict what the user can do inside of the system in case that, for example, an application gets compromised.
Yeah, I know that has been debated a lot, mandatory access control, because you're basically giving the user a very, often a very hard to use configuration, which could easily be fucked up.
Yes, that's why things like the Linux policy project exists. They try to provide a default set of policies for specific applications that are broad enough so that the application will work in the way that it's supposed to, but cannot do anything else.
Yes. It cannot call.
You usually need to customize them.
Yeah, of course.
But I mean, it's not the most user-friendly thing in the world. It's probably not the best way to start hardening a system. But if you have somebody that has some experience on Linux, for example, on administering Linux systems, he probably has enough knowledge to be able to modify and customize the policies, even if he has not done that before. You just need to be reasonably aware of what programs do and where they usually run, so you can modify the policies if it's needed.
And does Gentoo harden ship default with SE Linux and with Linux process? Default Linux?
Well, the thing with Gentoo is that you can choose. So there is a set of profiles that provides a Linux enable by default. You still need to choose if you want an enforcing policy or a targeted policy. But you can have that provided by default, yes.
Oh. That's nice. So you started using Linux, you set up your web server,
yes.
And then it just continued. Or what happened then?
Yeah, well, I eventually started finding and solving problems with Gentoo hardened. I ended up being the responsible for writing documentation of the project.
Okay.
A lot of the documentation was already written. I mostly had to keep it up to date. So it was not as much work as it might seem. But yeah, that was basically my first contact with these kind of things. A bit later, I started doing CTFs. That's a really fun thing because,
CTF, which are capture the flag security competitions.
Yes. You know how I did my first CTF? Because you're never going to believe it. So I went to a LAN party because I love, and I still love going, not gaming, but going to the LAN party, the kind of ambience you have there, it's really cool. You can
the community,
yes.
The feeling,
I went to this LAN party called E-Party that was mostly focused on free software, actually.
Okay.
And they were holding this CTF competition.
And at that time, you never heard of a CTF, or have you had? You've been looking at it.
I don't remember having heard about any. No. So the organizers of the CTF came talking to me. I was giving a talk on another topic, and they were like, "Hey, you are probably going to love this thing. You should totally do it." I checked the first challenge, and I was like, it was a JavaScript code. Basically, the password was part of the JavaScript or something like that. And I was like, come on, this is trivial. I can solve it like this. And he was like, yeah, sure, do it. And I was like, but I don't want to. It's just so trivial that it's boring. And he was like, no, come on, do it. You will enjoy it. So eventually he managed to convince me after persuading me for 3 hours or something like that.
You're very stubborn.
Yeah. And eventually he managed to convince me, and I was like, okay, if I do it, you will suit up. And he was like, yes. So I fell on the first trap, then I fell on the second. I think there was a third trick that I had to figure out, and then I managed to solve it. And he was like, not so easy, yeah? So then I was like, no, it was not. Let's check the second one. And I checked the second one, and the third one, and the fourth one. I don't remember which place I got. I think I got second or third place on that challenge. The cool thing is that I did develop my own tools for it.
Nice.
So there was some challenges on which they kind of expected that you could use standard developed tools that everybody in the field knew about, except me, obviously. So since I could not find the tools and I did not know the right names for the attacks or anything, I used was like, I'm going to write my own exploit for this. I'm going to write my own tool for. I remember a forensics challenge. I remember writing my own set of scripts and tools in order to get back the original file. And when I presented, they were saying how I was solving the challenges. They were like, "What the fuck with this guy?" I mean, they were expecting that I could just go pick a standard tool for doing this and use the standard tool for doing this. Then pick.
But you didn't go that route.
I did my own tools, and they were like, "What the fuck?" I mean.
This is too hardcore.
They were like, "Oh, so this is a real hacker, actually, because he doesn't just use tools like a script kiddie. He does know what he's doing." Then, eventually I kept doing a few more CTFs, and for other reasons that are not related to security directly, I was working with functional programming.
Okay.
When I was going to request an Erasmus grant, I went to my supervisor. It was a paid research project where I was basically working for a PhD student.
Mm-hmm.
So he told me that you should totally apply for Chalmers. They are the best at functional programming.
Okay.
And I checked the program at Chalmers, and sure, they are really good at functional programming. But back then, you know what they were better at?
Airline? No.
Security.
Security, oh yeah.
They had this full master program focused on security.
Yeah.
Security, and only security. And I was like, okay, we don't have this on Spain. I'm totally applying for this one. So it was a disappointment for my supervisor, of course, because I didn't go the functional programming way. But it was a really good choice. Eventually, I stayed in Sweden and I worked as a pen tester for a company and so on. So that's basically how my career developed. In fact, right now I'm back at Chalmers as a PhD student. I'm working for this project called RIOT. It's Resilient IoT. I know that resiliency and IoT, I mean, you know the old saying, the S in IoT stands for security and the P for privacy.
Yeah.
You haven't heard that one before? No. So the idea is actually trying to make IoT devices that are more resilient to attacks and harder to attacks.
And how is that done?
How is it going?
Yeah, and what's the plan?
So I have a few ideas that I am going to develop. Right now, I am working on a way to harden password security by moving the hard part of the password security to the client side or the person that is trying to authenticate itself. And the reason why I'm doing that is because most of the embedded devices that are used for IoT don't have the memory or the CPU or even the battery to be able to perform such steps by themselves. Yep. So you want to make sure that if you want to use this kind of strong algorithms, you basically have two options. Either you move that to a server somewhere else on the cloud provided by the manufacturer that has the power to do it, yep, or you move it to the client. The problem is that if you move this to the server, then you depend on the manufacturer. Oh, once the server stops existing or stops working, end of life, it's impossible to use anything. But if you keep that on the client, no matter what happens with the manufacturer, the system will still keep working. Because it will only depend on client support for the tools and so on. So yeah, really cool stuff. I think I should do a shameless plug here and thank MSB for sponsoring most of my research, because they are kind of who they are, the people that are indirectly paying for my salary. So
oh, okay.
Yeah.
That's cool. Could we jump back to Gentoo a bit?
Yes.
Like, Debian, they're providing not hardened Debian, but you're doing the Debian long time support thing, where they're basically having a different set of packages that are supposed to be more stable.
Yes.
And OpenBSD has an almost similar thing. Does Gentoo has hardened Gentoo? Does it have special packages?
No, but that is because Gentoo has a very different philosophy. Since you are compiling the packages on the spot, Gentoo uses a thing that is called a rolling release.
Oh yeah.
That means that instead of trying to maintain old versions of the packages, you are provided standard versions of the packages instead. And if you want to use the last ones, you can easily do so. You just compile them. So when you do a system update, you just get the information about which of the packages have been updated, and then you...
And then the package manager compiles it for you? Or?
Yes.
Okay.
There is only this one thing that you should take into account in Gentoo, and that is that we do have what we call a stable branch. Because the problem is that...
Of packages.
Yes. So we have a set of packages that are marked as stable, and then a set of packages that are marked as unstable. You can mix and match whichever way you want, but most users do use the stable branch.
Oh.
The idea is that once a package has been for some time unstable without bugs, or if there is a security issue, then immediately we make the package go from unstable to stable.
Okay.
I mean,
and the package maintainer does that? Or,
yes.
Yeah.
So once the package maintainer feels that the package is working well enough that everybody can use it without issues, then that version of the package becomes stable.
Okay, right.
Of course, there are some packages that don't have an stable version for one reason or the other. And then you can just do what we call keyword, that specific package, so that you can use only that, you can use an unstable branch of that specific package. You can also try to use unstable versions for everything. it's not very recommended on production because there is a high risk that something might not work. I mean, even with stable versions, every now and then problems arise, but especially for packages that are stable, but don't have that many unstable users, that the issues are detected before they actually happen.
Oh, yeah.
One of the packages I'm maintaining, for example, that is nftables.
nftables, which is the firewall?
So the original firewall for Linux, or the one that has been for the longest,
Hypertables?
is hypertables.
Yes.
nftables uses a different approach that is not strictly table-based, but instead you set up a set of hooks for the specific parts of the flow of the network flow that you want to track and analyze.
Okay.
It's supposed to be more efficient and more performance than hypertables, because instead of having strict rules, you can have sets as part of the rules on every part, and you can do more advanced control flows than what you can usually do with a standard table. The thing is that nftables, basically there is one kind of user for nftables, and this is people that use it on production.
Yeah.
I mean, I don't think there is that many people that care enough about nftables to use it on an unstable or a not so important system, because then you will probably use hypertables or something like that directly.
And does Gentoo ship with it ships with nftables?
It ships with both. You can choose whichever you want.
Ah.
So on Gentoo, you do compile your own kernel. You can choose to enable one or the other.
Oh.
Or both, and then, I mean, you should never
You can run both at...
Yes, as long as you don't do so at the same time.
Okay.
If you run both at the same time, you might end up with problems.
Yeah, because you have one rule in one system saying something else in another system. Yeah, that's...
But, yeah, the point is that you can choose whichever you want, and that's really, really cool stuff. As I was saying, the reason why I was telling this is because problems do arise on stable packages every now and then. It's not 100% problem-free. On the bright side, we have a lot less maintenance than what you would need on Debian, because all you need to do is to keep track of the software versions that are not causing a lot of trouble, and then mark them as stable, instead of having to backport patches to a specific version and so on. That takes a lot more effort and requires a better understanding of the software. And it's a lot easier to make mistakes in that way.
Yeah. So let's jump into crypto.
Mm-hmm.
You've been doing research in crypto, both privately and on.
Well, now I'm being paid for it.
Yeah, now you're being paid for it. But yeah. You've been researching the Petya malware.
Yes. Wow, that was a long time ago. So,
what is Petya?
Petya was a ransomware that appeared a few years ago.
Yes.
It was really cool and really different, because whilst most ransomwares would encrypt your files one after the other,
yes,
Petya did encrypt the part of your hard drive that tells where the files are.
It went straight through the...
Yeah, so the idea, this was a really smart idea, because you can only do that on the low level, so that's why it waited until a reboot happened before it did the encryption.
It's harder to detect.
Yeah. And the cool thing is that it can do so really fast, because the master file table, it's only a few megabytes of size, so in less than 5 seconds it can be completely encrypted. Whereas if you want to encrypt every file on the system, it's going to take a long time. You need to wait until... so that was a really smart idea. The thing is that different versions of the software have had different bugs in the way in which they implemented the cryptographic code. And the first version, which was the one on which I focused, had a really interesting bug, which... so they were using SHA-20, if I recall correctly.
SHA-20, yeah.
But they were using a 16-bit version of SHA-20.
Okay.
Generating 32-bit length
identifiers.
Yeah. So I mean, the idea is that in Chacha20 the word size is 32 bits, but they reduced it to 16 bits.
Okay, so they customized it.
Kinda. Yeah. I don't think it was. I don't think they customized it, but they didn't take into account that the instructions could be executed in 16-bit mode instead of 32-bit mode. There was only one exception to this: rotations. The rotations were made on 32-bit.
Oh.
So what happened was that basically you had when you were generating the key stream, you did all of this obfuscation of the doing additions and other operations, and then you had this 16-bit value that was placed on a 32-bit register. It was rotated with zeros at the beginning, or no, I'm not sure if I think it was with sync expansion at the beginning.
Okay.
So either zeros or ones, and then once the rotation was done, with zeros coming or ones coming from the other side, then you repeated the process.
Oh.
So if you kept track, and I did a program to do that, if you kept track of which bits affected each bit of the output, you could find out that very specific parts of the, very large parts of the output were affected by very few bits or only one bit of the input.
Oh.
So if you have one bit of the input that is the key, part of the key, and it's mapped to one bit of the output, then you could get a big part of the key. The other parts of the key, the first 16 bits did not contribute at all because of the 32 bits of the key, of each one of the words of the key, half of them were discarded because the algorithm was using the 16-bit mode. And then the 16 bits that were left, if I recall correctly, around 8 or 9 bits per element could be recovered. And the other 8 bits were generated from the first 8. So there was a direct relationship between them. So the thing is that if you sat down and did the math and the equations, and I did so on fucking paper.
Pen and paper.
Yes, I solved it with pen and paper.
Wow.
You could actually figure out what was the way in which the bits were being expanded and which parts of the key were replicated at the end of the stream, and then XOR it with the result.
And then you recover the key.
Yes, and since part of the key of the data that was encrypted was always the same, you could then use this with a known text cryptanalysis attack in order to figure out which part of the key was which.
Nice.
In fact, I started doing so because I did not do the reversing. Somebody else that was called Leo and Stone did the whole reversing job, and he wrote a decryptor that was using evolutionary algorithms in order to try to figure out what was the right key. So basically, he noticed that the more bits of the key that were right, the closer you were to the right key, until eventually you got the whole thing right. But he didn't figure out why that was working. And he was like, okay, if somebody can figure out why this is working, well, here is the code of the decryptor and so on. I sat down, I checked his decryptor to figure out how the Petya did the actual encryption. I saw that it was okay, it's 16-bit version of Chacha20, and there is this modification.
How did you see that?
Well, I basically had the full code in Go of the decryptor that Leo.
Yes.
So I basically read the code.
Oh yeah.
And once I figured out from his code what Petya was actually doing, I could figure out what was wrong. And eventually, after thinking about it for hours and hours and hours and hours, I figured out, wait, this bit, let's see, it moves here, it then moves here, it moves here, it moves here, but it doesn't get modified across the whole process. And then it gets XORed with the output. Oh.
Then the light bulb moment. Yeah.
So, well, actually, it's not exactly that way because the bit gets added to the bit gets added to the key at the end, but pretty much that's what was happening. As in, a specific bit was not modified all the way, and at the end, one specific bit of the output will depend in at most 2 bits of the input. So it's really easy to test which is the right value for each one of them.
And then did you download the ransomware and try it out, or how did you test it?
Well, I basically...
Give me ransomware.
Kinda, yeah.
Fuck me up.
I got a sample of the ransomware and I tested my method and it worked.
Nice.
I also verified that the questions were correct and I did right, but I never published it as small decryptor. I mean, but the problem is that by the time I had the decryptor and everything, Leo's decryptor worked reasonably well. It was just a bit slow because it had to do all this artificial intelligence approach to evolutionary algorithmic approach to solve the problem, whereas mine was instantaneous. It just solved an equation and it solved the problem.
Mm-hmm.
But there was kind of no point. I mean, there was a new version of Petya, the old one was not so popular, and I mean, you had a decryptor already, so why care?
What happened with the new version? They published another cipher, or
yes, they published a modified version of the cipher that had a different set of bugs, and it was not such an obvious flaw in this one that you could literally do it with pen and paper like I did with the first version. But still, it was weak enough that you could use a GPU in order to obtain the key. There were some other weaknesses that allowed you to figure out the whole thing. And I think the third version was the one that could not be broken. Because here is the funny thing. The developer of Petya, unlike many other malware developers, had his account on Twitter.
Yeah.
And he was like talking about everything he was doing and
like
challenging and provoking the research community. You cannot break this. He went by the name of Hanus,
Hanus.
Yes, the bad guy from the Golden Eye movie.
Oh yeah.
The one the Russian guy that is smoking. So, and he even used quotes and so on. He seemed to be a really big fan of that.
Oh yeah.
I mean, Petya is literally the name of one of the satellites.
It is.
Yes. So
that's a huge fan there, right there.
Yes. So the thing is that he kept provoking the community. Mostly, he liked to taunt a researcher called Hasserzeit. That was and is still one of the biggest experts on that specific ransomware. He spent a lot more time on doing research on it than I did afterwards. And when the NotPetya thing happened a few years ago, that virus that used code from Petya but was not actually Petya, that made it completely impossible to recover your data, unlike the original versions of Petya. Well, when that happened, we were trying to break it up, and he said, well, I don't know if this might help or not, but here is the master key for decrypting everything that was encrypted by Petya.
Wow.
Like that.
Because he felt defeated, or?
It was not that he felt defeated, for fuck's sake. I mean, I can kind of understand how he was feeling, because think that you make this really cool thing. I mean, sure, some people is using it for bad things, but it's bad is. I mean, you are basically asking people to pay you to recover their files, but they can't recover their files. The damage is not permanent. You pay, nothing happens. And then this guy comes and says, I'm going to make a fucking destruction tool with this.
Yeah, gonna watch the world burn.
Yeah, of course. He probably was like, shit, this is not what I intended. I mean, this is mostly speculation, but I do believe that he probably was some kind of hacker that had that as either a hobby or a side way to get income.
Okay. And was it public how much they made, or?
No, they never explain. Take into account that usually with this you don't sell. When people develop this kind of malware, they don't usually deploy the malware themselves.
They sell it to other people. They
sell it to somebody else that
takes the risk.
Yes. And usually they get a percentage or they get paid a fixed amount of it.
So it's basically a developer for hire then?
Kinda. I mean, not the kind that I would like to, but you should be careful with this because there is a big risk on it too. I'm not sure if you have heard about this guy called Malware Tech, the one that stopped the NotPetya attack.
Yeah, he discovered some domain
Yes.
name or something. Yeah.
So
the British guy.
what you might not know is that he was a malware developer long time ago.
But it was,
and his knowledge about how malware works and reversing comes from the fact that he was developing malware a long time ago.
But is it pub? Because I think he is a malware developer, but it never has been.
He is not anymore.
But it's never been public that he has developed more. It was only speculation that
no,
he was.
it's not a speculation. So what happened was that he went to the United States.
And then he got
detained by police there. Yeah. And there was a trial, and according to the information on the trial, I think he confessed, or he in some other way accepted that he was the one that did the development. He had to serve some time on prison, I think, or detainment.
Well, he was charged for developing Petya.
Not Petya.
Not Petya.
He was charged for developing Kronos.
Oh.
That's another
it was an earlier
yes.
malware.
That's a banking malware.
That's a banking malware. Oh, sure.
It's a malware that tries to use your banking information for. Thing is that he did develop some part of Kronos, and he did not develop everything. But since he was still part of the development of that specific malware, well, he was indicted for that, and he had to serve some time, as far as I know.
Oh.
He's out of jail. As far as I know, the judge took into account a lot of factors, like the fact that he had stopped this other attack and that he was working precisely in order to thwart attempts.
People, yeah.
Yes, from what he was doing in the past. So there was clear rehabilitation in him. I think he's still in the United States, because as soon as he gets out, he will not be able to get in because of how United States laws work. But I don't know much more about him. I don't follow Marcus so closely, you know.
All right. So what happened to NotPetya?
What happened is that basically NotPetya had this specific domain name that he tried to check, and if it got a response,
and he was able to reverse engineer it.
No, he just found that it was even more fun than that. So this guy found that the domain that Petya was requesting this domain when he was testing the virus, and he did the most logical thing on the world, since he knew that developers used this kind of domains in order to
in a LAN somewhere.
Yeah, so he was expecting some kind of command and control or something like that to be there. He found that the domain did not exist, and he bought it.
Yeah, that's smart.
And then as soon as he bought it, Petya tried to check the domain. The domain was there, and since the domain existed and was a black hole, Petya thought, Petya did not do anything. And the reason why they did that is speculated that either one, the developers had this as some kind of safe word, or two, that is more likely, the developers used to try to detect, try that in order to try to detect when the virus was being run inside of some kind of sandbox, to try to make figuring out what it did harder.
And this was combined with Samba exploit.
Yes.
SMB.
Yes.
Exploit, yeah.
So basically, NotPetya was using NSA. SMB and I think a few other ways to spread. And then the payload it contained, aside from the payload to spread, was basically a broken version of Petya that. So it showed you some window also saying that your files have been encrypted, yada yada yada. That said something like WannaCry, if I recall correctly.
Oh yeah.
So WannaCryptor or something like that, and that's basically where the other name comes. I mean, it was called NotPetya because obviously this was not Petya.
Yeah, that's an innovative name.
It uses Petya code, but it was not Petya.
Yeah. Very innovative developer there.
But the name of WannaCry comes from the actual window that it shows, saying that your files have been encrypted, yada, 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 yada.
Do you wanna cry? Yeah.
You know what is the funny thing with that?
What?
So
Wanna tell me?
Yes, this is going to be fun. So after Marcus detected and registered the domain, some other companies considered that the domain was malicious and they prevented resolving it.
So DNS resolver just block it, or?
Yes. And inside the people that was doing that, one guy was still spreading because he tried to check if the domain was there, but it was not because the resolver stopped it.
Yeah.
And then it said, "Oh, good. Then I'm going to encrypt everything and keep spreading."
Oh. They fucked it up.
Yes.
They fucked it up.
It was a serious mess up.
Yeah, it was terrible. Huge. I mean, yeah, if you get combine ransomware with the NSA exploits, then you.
Well, the surprising thing is that nobody did try that before.
But I mean, people must have tried that before.
Exactly, that's the point. I am surprised that nobody did try to combine ransomware or some other kind of malicious payload.
But this was because this was related to the Vault 7, the leak of the technical data from the US.
Yes, but the leak of technical data had already happened 2 months ago.
Yeah,
and source code was available. There was literally nothing preventing any other random person from picking up that code and writing his own exploit and his own virus. What is surprising is that it happened with a thing like NotPetya that was completely malicious and not in the sense that it was a destructive tool. Instead of with what have been more logical, some kind of banking Trojan or some other kind of proper ransomware that allowed you to recover the files afterwards.
Yeah.
So it's kind of surprising that somebody actually wrote a destructive tool before the people that is actually making money out of these kind of things did write a tool to exploit it.
Yeah.
I know that after NotPetya there were some other waves of other ransomwares and so on to try to exploit this. But of course, after NotPetya, people had mostly applied patches and were more careful. So
they spent more on security.
It's not that they spent more on security. They had stronger firewall rules and most systems were patched, so the impact was a lot smaller. It's similar to what happened with Mirai. The first users of Mirai were really big.
Yeah.
Because they made a really, really big botnet by hacking embedded devices and IoT devices.
Yeah.
And afterwards, as more and more people were targeting two same devices, the network was splitting into smaller pieces.
Yeah.
So the Mirai network probably still has a similar amount of devices as it had at the beginning, but all of those devices are controlled by different people. So the amount of total damage that can be done is smaller. If you have 1 million devices controlled by one person, the amount of damage that one person can do is significantly higher.
Yeah,
if you have 1,000 devices controlled by 1,000 people, different people. So, well.
Yeah, Mirai was also very special. I know I was running a honeypot, collecting CNC servers for Mirai, and there was just. When Mirai went public, it was just so many people that tried to use it, and I was seeing new IPs every day. And yeah, it's exactly what you're saying. Once someone gets it to work and they start talking about it, everyone runs for the hill.
Yeah, everybody tried to use it, and then the amount of the impact that they could make was smaller.
Yeah. So, what are you excited about in the future of cryptography? And where do you see the world heading in the...
In cryptography?
Yes.
Well, it's fairly clear right now. Most likely, people is working nowadays a lot on developing post-quantum cryptography. That is, cryptographic algorithms that can resist the existence of quantum computers, not because they exist now, but because they believe that they will exist on the upcoming 20 or 30 years. Take into account that usually you want to make sure that the data you encrypt is stays secret
for a longer period,
a long amount of time. So there is a risk that if a quantum computer came into existence in 30 years from now, everything that was encrypted today could be decrypted if you had saved copies of it.
Yeah.
So that's basically what is happening right now, mostly on cryptography. I think that's the hottest topic of them all. Another very hot topic, and that's part of my research too, is developing cryptographic tools that can be used in a way in which making mistakes is really hard. You know that in general, with most cryptographic systems and cryptographic algorithms,
the implementation is
if you implement the algorithm in an incorrect way, everything breaks.
Yeah.
So the libraries like Lipsodium, for example, are coming into existence to try to create cryptographic primitives that are misuse resistant, that are really hard to use incorrectly, and that can be easily integrated into your code.
How do we solve that?
Well,
sorry for interrupting.
My sincere opinion is that there is no one-size-fits-all solution, because, I mean, there exist solutions that work for most people. Concepts like the box abstraction that Lipsodium uses, on which basically you have some kind of library call that you provide a password, or you provide a public key and a private key, and then it generates an encrypted text that can be decrypted by the other side. Mm-hmm. All of that is really cool.
Yeah.
And it works really well for most cases. But when you start going into embedded systems, or systems that are more limited in resources, you end up having to develop your own techniques, because standard techniques usually don't work for everything. I still think that if we manage to have solutions like Lipsodium, or for example for the password hashing stuff that I am working on, that are easy to use and that can be used directly.
Cross-platform. Yeah.
Yes, that they have to be basically easy to use, cross-platform, and provide a clear API that is really hard to misuse.
Yes.
So if you can provide tools like that, then at least for the most common cases, everything will be safe. Sure, a car, for example, might need to have a cryptographer saying this had to be done this way or this other way, and this algorithm should be used instead of this one. But when you have like two big computers with a lot of resources talking with each other, and latency, for example, is not so important, as is the case with most web applications nowadays, for example, you don't need to have the best specific cryptography that will give you 100% performance. Usually 75% performance or 60% performance is good enough, because you don't care about using a little bit more data, or about things going a bit slower, or needing more CPU. Of course, when we are talking about embedded systems over constrained links and with
smart devices,
that kind of situation is different, and you might need specific algorithms and specific protocols that are as lightweight as possible. But for common purposes, you don't need that.
Yeah. That's an interesting thought, yeah.
So I think those two are the biggest developments that we are going to have. I do know, for example, that Bitcoin will not like it the day that quantum computers happen.
Because of the key generation, or?
Yes. So I know that Martin Ekeroch, he's a researcher in Stockholm, is working and publishing information about how to use sieve algorithms, quantum sieve algorithms, for cracking the different implementations of elliptic curve algorithms, DSA, RSA, and so on. And I mean, RSA is fairly trivial because that's factorization of integers.
Yes.
DSA and ACDCA, elliptic curve DSA, are a bit harder, and he was publishing proper algorithms that can actually break it with a quantum computer. And
Wow.
yeah, he was presenting at SecT last year actually.
Oh. Then his talk is on YouTube probably.
Yes.
I should check it out. What's it called? You know that?
Martin Ekero.
Martin. All right.
I'm saying the name in Swedish, so.
Martin something. SecT.
Martin Ekero.
Martin Ekero. All right.
So, well, he's doing a lot of cool research on quantum computing. He's working for the military.
Oh. Ouch.
So, you know, when a guy that works for the military says we have published this, you should be careful about this, and this.
Then it's bad. It's bad.
Then you listen.
Yeah.
Because it's probably the level of bad that, you don't want to have.
And he's a cryptography researcher for
he's
the Swedish military?
Yes, he's working on the Swedish military. I don't know specifically his assignments. But I know he's working with cryptography and I think also auditing of cryptographic systems or something like that. I don't have a clue. I remember my first contact with him was actually when I did a pen test for a public owned company or some government institution or something like that.
Okay, state-owned entity.
Not by state, I think it was either city or regional level, but yeah, something like that.
Yes.
And as part of my report, I was trying to provide guidance of which kind of cryptographic primitives they had to use. And since this specific organism has this policy that if you have a public institution needing help with cryptography, you should contact us with help, blah, 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 blah. I wrote to them and I basically sent them an email asking them, well, I have this situation with this specific state-owned entity or government-owned entity. Yep. And I am trying to give them advice and recommend them algorithms. Do you have some kind of standards or a book with standards or something like that?
A dummy guide.
Not dummy guide, but you know, like
easy to use.
This is
easy
what
to understand.
Like NIST, for example, in the United States.
Best practices.
Yes, a reference list of encryption algorithms and so on that I can refer them to. And he was like, well, we at the military are working with this specific set of public standards of the NATO, and if you want to refer them to something, you probably should use this. And I did so. I heard that the customer...
Has NATO published public...
I'm not completely sure the specifications for NATO are...
Isn't it unusual that the Swedish military refers to NATO when they're not part of NATO?
Yes, but since they are working on this standard with other European entities that
then it's logical, yeah, of course. I mean, and what did he send you? Did he send you best practices or?
He referred me to a document of best practice that I sent. I sadly don't remember the name. It's been a few years since then, so. But it was a really cool document. I mean, I remember that they were recommending, for example, different kinds of elliptic curve, minimum bit sizes for different algorithms.
Nice.
And they recommended, I think, for example, for secret shading. That's a really cool thing on cryptography.
Yeah.
They were recommending using Samir's secret shading scheme.
Oh yeah, that's popular, very popular.
Yeah, you know, it's that one where basically every entity defines an equation, and then the point on which all of those equations matches is the key.
Yeah.
So the idea is that since you can have an infinite
number
set of
keys,
points, until you manage to get a specific point, you have infinite possibilities. That's really cool stuff. So, well, it was a really good read. I definitively recommended them to use this as a guide and reference because it matched with the best practices I already knew, so it would have been pointless not to do so.
And do you know if they implemented that? And did you follow up on that? Or?
I think they implemented that.
Awesome.
I usually don't have so much of it. I mean,
you don't follow up.
That
so
was
much.
at the time when I was working doing pen tests for a big company.
Yeah.
That was being hired by them. So
they probably got the report and then.
Yes.
Buy.
I hope that they implemented it, but since I was not the one that was
pushing them, yeah.
Yes, I don't have a way to know. I mean, you know that especially when you are working for a company, you don't get the chance to ask your customer how is it going with this.
No, it's often very separated.
You don't
One
have direct
person do
contact
this
with
and
customers and so on.
No, you don't get the wonderful word of customer management and walking the customer hand in hand and doing
Yes.
marketing and all that wonderful sales PR stuff.
Hey, there are a few cool stuff with that. I mean, being able after you have done a work to follow up on your customers, see what they think, what could be done better, telling them that you will be there for them if they need something. That's really cool. I mean, it's one of the cool things from having my company that I totally not miss not having from when I was working for a company. On the other hand, having to find customers, that is a bit more painful.
Absolutely. I mean, yeah, I totally I deal with customers from almost a daily basis. I feel, like yeah, exactly what you're saying. You get to watch the customer grow and get to be part of that journey, which I think is it's really nice. Yeah, you often also make a lot of good friends doing that, which is really nice. To get that nice human contact. So, what's in the future for Gento?
Well, supposing that it does not stop existing,
there's a chance.
There is a non-nil chance. I mean, the community of Gentoo has declined over the years. I'm not totally sure if it's only my impression or if it's a real thing. But I do have the feeling that there is less developers and that the ones that are there are becoming less and less active over the years. And a lot of developers have retired. I don't think there is so many new blood coming to the project. But if it keeps existing, it will still be a beacon of a beacon for these people that like to be able to have choice. So it will be a beacon of choice. That's the word I was looking for. It will be a beacon of choice for all the Linux users in the world. But that's supposing it keeps existing. I mean, let's face it. I mean, I think I have kind of the same feeling with almost everything. For example, in Gothenburg, there is not been an active hacker space in a long time.
Absolutely.
It's been already 5 years or something like that since
the Gothenburg hackerspace
was active. It still exists. I'm part of the board, but we don't have that many activities, you know. And
dies out.
If it was only the Gothenburg hackerspace, I would be completely fine with this. But there is not been any other new hacker spaces that have been taking up the place of Gothenburg hacker space.
There is the Inbyggd Frihet, small group doing Libre boot stuff.
Yeah, but it's not the same thing.
Yeah, exactly. Yeah.
I mean, the idea of a hacker space is to have an open space to where everybody can come.
Yes.
And share a common interest about finding creative solutions to problems and so on, and maybe security. Yeah. Spark Nasted is also either disappeared or inactive. The hacker space in Malmo, pretty much the same. And if you check in general over the whole world, most places there is less and less hacker spaces and less hackers over time. Probably as an indirect consequence of the fact that the security industry has become an economy in itself. It has become an industry.
Yeah.
And there is less people that do these kind of things because they find it funny, and more people that have to do this because they get paid for it. So,
but creativity and creative people are they're always gonna be around, and I think there always gonna be a demand for it. Like in Gothenburg, you have a lot of exchange students that are interested in creative. You have a lot of good engineers.
I'm not putting that into doubt. The problem is that if that people don't have the same interest on hacking that the people before them had, then hacker spaces will not exist.
Yes.
Because there will not be a
And that's terrible.
Yeah, and I feel it's the same with Gentoo. I mean, Linux probably has now more users than ever. But how many users do you know that want to sit down and compile everything?
Not a lot.
Not a lot, and they have to have a really strong reason for that.
Yes.
And I mean,
how would you motivate those people
to use Gentoo?
To sit down and go through the process?
Well, I sincerely think it's a really good learning experience. You discover a lot of the innards of Linux that you could never think existed in the process of having to make everything work. You learn a lot every time you mess up, and when things go awfully wrong, you learn a lot of cool new things because you learn what you did wrong and why this caused everything else that happened. But I sincerely think that if you are using Gentoo on your systems, either you have enough CPU cycles to be able to compile everything, and that means that you, for example, have a desktop that you are not fully using every time, and I think this is actually the biggest point of using Gentoo, you have a large farm of systems on which you precompile the packages on one specific system and then distribute the compiled versions to all of them.
Yeah.
If you have a lot of systems that are the same, then you can set up the compiler flags so that it optimizes everything for a specific that kind of system.
And can you auto-build it then? Could you automatically build it?
Yes.
Awesome. That's great.
You can use tools like Tinderbox in order to precompile the packages that you expect to use.
Nice.
And then you use what is called a bin host. That's a host that distributes binaries version of the packages.
Okay, yeah.
And then these versions are used automatically by every other system. If you need a specific system to change some of the settings of a specific compilation process, then you can recompile that specific package on the system, but you don't need to recompile everything. And you can always modify the binary host so that it will provide the different flavors of the package with the specific settings you want to use for one or more systems.
Do you know if there's any bigger organization that has this in production right now?
Yes, I do. We are kindly asked not to talk about them.
But there are?
There are.
Okay. And their experience with that? Do you know they're happy running it?
Well, most of these people do hire a Gentoo developer.
Okay.
That's why I do know that they exist. I mean, we usually talk about this kind of stuff at FOSDEM or in internal discussions and so on. But we are usually requested not to share that information with.
Yeah, of course.
Mostly because they consider this to be a sensitive topic about the security of their systems and so on.
Don't expose too much.
Yes.
So I know we're having a lot of interested listeners that are interested in Linux, BSD, and in technology overall. So if someone wants to try out Gentoo, how are they?
Can I ask you one question?
Yes, interrupt me.
You mentioned this thing, BDS?
BDSM? No, that's our other podcast. But we can get you on that as well.
Sorry. So I thought you talked about this BSDM thing or... No.
You know this thing you're stealing packages from?
You mean like OpenSSH?
Yeah. OpenSSL, LibreSSL, and...
yeah, exactly. That is one of the things, for example, in Gentoo, you can choose between OpenSSL and LibreSSL.
Nice.
If you want to use a full LibreSSL-based Linux system, you can. You want to use a full OpenSSL-based system, you can. You set up the appropriate compilation flags. That's called a use flag. So, for example, you could use equals LibreSSL and then a mask the use flag because I think LibreSSL is masked.
Yeah.
And there you go. You have LibreSSL everywhere.
And if I'm not mistaken, LibreSSL is compatible with the OpenSSL API.
Not completely, but partially.
It's kind of.
Yes.
Yeah. So it will not break everything in your system.
No, because most of the packages that do support LibreSSL do so
through
being aware of the differences. So. But you asked me how to start on Gentoo.
Yes. How does a new person start?
It's really
That's
simple.
never heard of Gentoo before.
Okay, it's really simple. You download an ISO of the installation media. You burn it on a CD, or you burn it using something like UNetbootin or similar tools on a USB.
Yeah.
Then you start from that USB, and that will start a full Gentoo system for you. And then from that Gentoo system, you can download a guide that is called the Gentoo Handbook. And that is a step-by-step guide explaining you how to install Gentoo.
So you boot into a live system, or?
Yes, and you use that in order to install Gentoo. The cool thing is that with a few exceptions, most of the commands that you need in order to install Gentoo are either part of the Gentoo version that you will download afterwards, called the Stage 3, or are provided by almost any other Linux system on the world. So you can actually install Gentoo using a live CD for almost any other Linux system.
Oh, nice.
Yes.
So as long as you have a Linux kernel, then.
Yes, you have a Linux kernel, you have the usual set of new tools, that is basically some disk partitioning tool, some tool to format the partitions that you create, and then tar. And that's pretty much everything, and a text editor.
Yeah.
Those 4 tools are basically everything you need in order to start a Gentoo system. Because at some point after you have extracted what we call the Stage 3, that is basically a bare bone Gentoo installation, then you chroot into that system.
Okay.
And you keep doing the rest of the installation from inside a proper Gentoo system. That is the system you are installing.
So you chroot into a Gentoo environment.
Yeah, basically, the way in which a Gentoo installation works is that you set up partitions and everything for the Gentoo installation you want to use. Then you mount that partition somewhere. Then you download and extract what is called a Stage 3, which is a minimal Gentoo installation.
Okay.
And once you have extracted it, you chroot. So you go to your terminal to go inside that Gentoo installation and use everything from that Gentoo installation. And then the rest of the installation process is done inside of Gentoo itself.
Oh. That's cool. That's a bit unique as well. Yes. Is there any other system doing this? Do you know?
I know that Debian has the bootstrap tool, but you still need the tool in order to be able to do a bootstrapping process. I know the reason why I like this on Gentoo in particular is because at one of the companies I was working for, they had these servers on OVH, and they provided this Debian-based recovery system. And they, of course, did not provide a way to have Gentoo pre-installed on the systems.
Oh, so you just installed
So I basically made a set of scripts. They added it. It was like, okay, so all I have to do to set up the system is request that they start with the recovery image. Yes, done. Now I'm inside of Debian. I do the first part of the installation with Debian, and then I chroot inside of Gentoo, and everything else is done inside of Gentoo. It's really good stuff.
Nice.
The thing that can be most complicated for people that is starting with Gentoo is compiling their own kernels. And a good way around for the first iterations is that you instead use the kernel to compile the kernel for you. It's not as cool and as minimal and as fast and as secure as you can do by compiling things by yourself, but it's a lot more simple, and it's a good start because it's a lot easier to modify a kernel configuration or a kernel compilation configuration when you have one working one than have to start from nothing, because it's reasonably easy to make mistakes, and it's a lot easier to do so on an iterative process where you can always roll back to the prior version if something is wrong, than having to figure out what you modified, what you did wrong when you don't have anything to compare against.
So when you do a kernel upgrade in Gentoo, do you save the old kernel? Or?
When you do a kernel upgrade, basically you download the source code of the new kernel, and that gets installed for you. And then
what happens to the old kernel?
So the kernel is the only exception of the Gentoo packages. It's the only one that is not compiled automatically.
Okay.
So
you download it
basically the source code of the kernel is downloaded. to /user/src.
Okay.
So yeah, then there you go to the specific Linux version you want to compile, do copy the old configuration, for example, do make old config.
Yeah.
So you will only be asked for the things that have changed in the configuration file. Then when you are done, I usually do make menu config to make some minor changes, or I keep taking notes of things that I should change that the old config is not asking me. Then I save the settings with the menu config tool. Then you do make space -j and then as many processors as you want to use, as many threads as you want to start. And when it's done, it's make install and module space modules dash underscore install, so that the kernel is installed and the modules are installed. And the kernel itself will install itself correctly on /boot, including the version number. So new versions of the kernel will have a different version number.
Okay, so if something goes bad and you want to revert back, you can do so.
Yes. Also, when you do a make install, the last version of the kernel that is in there will be renamed to the same version .old.
Oh yeah, smart.
And then you can use grep or whatever tool you want in order to boot the old version of the kernel. You can also manually rename the kernel to secure or working or whatever, so you can keep track of that specific kernel for the specific boots that you want to do. In Gen 2, with the exception of Gen kernel, it's not that common to use init/ramfs unless you are also encrypting your hard drive.
Mm-hmm.
So it's reasonably easy to create kernels. And since you are compiling your own kernel, you don't care about generating an embedded init/ramfs inside of the kernel that does everything that you need. So you can have a single image that does everything for you. It contains the kernel, it contains the init/ramfs. You are not using modules because you have everything compiled in.
Okay, yeah.
And since you have everything inside of there, then once this is working, you just save it as the .working image, and you can always roll back to it when you make any changes that don't work.
Nice. Very nice.
So yeah. Any other questions?
I had a nice list, but I forgot it at home. What have I missed?
I don't think much. I mean, we have talked about my work at Gen 2. We have talked about some of my research on cryptography. We have talked about some of my current research topics. We have talked about my work. Kinda. I mean, we haven't focused so much on what I was doing when I was working, for example, on the cryptocurrency exchange or so on. But I don't think you have many questions about that, do you?
Not a lot.
No. Okay. Then, yeah, that's basically it. I mean, unless you want to ask me things about pen testing.
I think we should save that for a future pen testing episode.
Makes sense.
Absolutely. So, what's the future look like? You're gonna keep on PhDing?
Yeah, my objective is to get a PhD. I have 4 years left, more or less. By then, I should have published 5 research papers. That's at least my objective. Hopefully 5 big, serious contributions to
the internet.
To the Internet of Things, security. Let's face it. My objective is actually making secure systems. So hopefully, most of my research will not be only for IoT devices. The requirement I have is that my research has to impact IoT devices. But there is a big difference between has to impact IoT devices and has to impact only IoT devices.
Yeah.
So most of the research I'm doing, I'm hoping will be broad enough that it will be applicable to mostly every other system and not just IoT devices. And well, once I am done with my research, I will either go back to working on my own company. I still do work on my own company. I am available for hire in case somebody actually wants to try to convince me to work for them.
And how do they do that?
They just write me an email.
And your email address is?
Klondike at klondike.es, as in Spain, because that's where I was living back then.
Yes.
So, sure, that's an option, but once I am done with my PhD, I will either try to find my own funding for research, or try to find a research job on a topic that I am really interested in, like this one I am doing now. Or if neither of that works, that's plan A, as I call it. I have plan B, that stands for business, that is going back to my own company and doing my own business, instead of plan A, that stands for academy, keeping doing academic
So you
stuff.
got plan A and B, it's academia and business.
And actually the A and the B have a meaning.
Yeah.
So yeah.
What's C? Is it computers or
I guess plan C would stand...
compiling?
I wouldn't be surprised if plan C stands for crying or cracking.
Oh, yeah.
I mean, it's not well defined, so...
You haven't got the P pulling your hair out. Or
I mean, the bad thing is that by now I know enough about the criminal world to be
don't
able...
say too much.
No, I think it's important to say it. I know enough about the criminal world to be able or feel comfortable doing crime myself, but I still have strong ethics, and that's why I don't feel comfortable doing it. Not sure if you understand.
Okay.
As in, I could feel comfortable from the sense of I could be able to pull up with it without being cuffed.
Okay.
But that's still unethical, very unethical. I don't feel comfortable with that last part. I mean, it's like everything. You could, for example, sponsor a revolution, and you will probably be completely fine with that, because if you sponsor a revolution, it's because you don't like the system and you want to change it, or you help a revolution. But there is a big difference between helping a revolution or helping a set of activists that does not pay, and getting your money by fucking up the life of people. And I don't feel comfortable with that last part.
No.
I mean, I think using my knowledge and using my tool to generate a better society is positive. And at
Absolutely.
times that might entail having to do things that are not legal, but that you feel are correct to do.
Yes, of course.
I mean, think for example about Edward Snowden, what he or what Chelsea Manning did. What those two people did is completely illegal. That does not mean that it was wrong for them to do it.
Yeah.
But then there is things that are illegal and wrong, like, for example, trying to make money by extortionating people by creating ransomware, for example.
That's terrible.
Or stealing money from people's accounts using...
taxation.
Not taxation. I was thinking about Trojans, but... Yeah, you know, but on the other hand, of course, there is things and things. I mean, you usually have to take into account the impact of what you are doing.
Of course, you're responsible for your actions.
Yes, I wouldn't feel so bad from stealing, I don't know, $1 million from Jeff Bezos, for example.
Okay.
Because he has so much money, he will probably not suffer anything from it. You understand?
Yeah.
But I do care a lot about stealing $1 from this guy that makes $1 a month somewhere in China. Because you are basically taking all of the nourishment and all of the economical resources that it has.
Yes.
And as you can see, you could say, but $1 million is more than $1, but the impact it has on the people is very different. In one case, the impact is very small because it's $1 million, sure, but of a fortune of billions. In other cases, like $1, sure, but of a fortune of $1. You understand?
Yeah.
So that's basically how I see it.
But what do you want to do? You want to stay in the... keep doing awesome projects?
To be sincere, what I want to do is to keep doing research.
Awesome.
And I hope I can contribute to the society with my research, with positive...
social change.
Social change, yes. But I understand that that's not always possible. And In the worst case, I will go back to what I was doing lately before I started my PhD, which was working to get money so I could use the money to sponsor my own research. Not that worked reasonably well. I mean, if you make enough money that you can pay your living for 2 or 3 months every month you work, then you can work 1 month and then do research for 2 months.
Yes.
Or 1 month, and everything was well.
Yeah, absolutely. That's.
If people that is listening to this is interested on these kind of things, I recommend that they approach their bosses if they are working for a company and talk with them about their ideas, because most will be reticent at the beginning, but if you can make it in a way in which they feel that they will not lose anything out of the deal, they will have a hard time saying no, unless they are stupid.
Absolutely. I mean, they're all often business people, and you.
Yeah, I mean,
you should always, like, as a ground pillar, you should always, do what makes you happy, because that increases your quality of living dramatically.
In my case, what I did since I was working as a consultant,
yes,
is that I approached my boss and I told him, you see, I'm actually working for you for customer projects, I don't know, 50-75% of the time. You can pay me for working and doing nothing for the rest of the time, or I can, and I will happily take the time off, do whatever I want to with my own research, and then go back to work when you have a project for me. And of course, when he did the math, he was like, well, that means that I actually win more money out of having you here.
Yeah.
And he's like, yeah.
He was saying dollar signs. Ding, 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 ding.
Yeah, and I was like, and he was like, and that means that you actually will be working on research projects that can be impactful and that can make it easier for me to hire you to somebody else.
Yeah, because that will actually bring up your value, which will bring out
the company's value, exactly.
So it brings out the reputational value.
Exactly. So he was like, what is the trick here? And I was like, there is no trick. It's literally the deal I'm proposing you because I want to do this.
Yes.
So
that's awesome.
That's basically the deal I closed. A bit of time later, things had changed a lot, and that's why I started my own company.
Absolutely. I think if you're listening to this and you're going in the same kind of thoughts, I think you should actually do something about it, because I think that's the hardest part for most people, is actually acting on it.
Well, in general, I mean, as I said, basically you have two chances. Either you manage to make your boss realize that they will win out of doing these kind of things with you.
Yes.
Or, well, it could be that, of course, there is no way in which the company can be winning, in which case it's logical that they decide to say no. But most often they say no because they don't realize the impact and the benefit that it could have to them, or to the company they work for, actually.
So bring that out in an easy to understand way.
Yes, try it. I mean, it's the same as when I was doing pen testing, but we can talk about that on another episode. When I was trying to propose security improvements to my customers,
yes,
I was focusing on two things. This is the impact of not doing this. This is how bad it can get for your company.
Yes.
And this is the real cost that doing this is going to have. As you can see, the cost is little. In my case, the cost was none. But the impact of not doing this is that you will pay me when you did not have a project for me, which was some specific amount of the time. So if you don't do this, you lose money. If you do this, you win money. And once you talk about these kind of things in terms of money, they usually do understand it perfectly.
So get it into numbers. Mm-hmm. Is the key take point from this.
Basically. You don't need to provide specific numbers, but you need to make it clear that the numbers are there for you.
Yes. Awesome. So we covered a lot of ground. I'm so happy that you decided to come here on the podcast, and you have to do it again. We will force you.
Well, you know, with most of the airspace closed, it's not as if I had many chances not to. The best trick I could pull out is picking up a train somewhere and then trying to disappear that way.
So if we have any listeners that are training conductors, they know what to. We will send you a picture of Klondike here to grab him while you can.
Yes.
Awesome. So where do people stalk you, follow you?
You can follow me on Twitter at Klon.
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 Yes.
Uh,
Your blog?
I have a blog, but I don't write there so often. And in general, if I write there, it's because it's big stuff that cannot be summarized in a set of tweets. My blog is on klondike.es/clone. I also have GitHub and other stuff, but if you are following me on my GitHub, then you are getting too personal, I guess. So
awesome. So thank you so much for spending the time, and let's have you back in the future.
Yes.
Awesome. Bye.